Okay, welcome back. So in this module, we will explain how we can use a multiplexer to implement digital logic. So here is a statement. For a logic function with n input variable, you will need 2 to the power n is to 1 multiplexer. What does it mean? It means for a logic function with one input variable, where n equal to 1, you will need 2 is to 1 multiplexer. For a logic function with two input variables, you will need 4 is to 1 multiplexer. And for a logic function with three input variables, you will need 8 is to 1 multiplexer. So here is an example where you are asked to implement this Boolean expression given by the function of a, b, c that is equal to sum of the following mean terms. The mean terms are 2, 3, 5, 7, and use a multiplexer to implement this one. So of course there are three input variables, that is n equal to 3. So as we've said before, you need 2 to the power 3 is to 1 multiplexer. That is, you need 8 is to 1 multiplexer. So here is a schematic of 8 is to 1 multiplexer. You have 8 input data lines starting from I0 to I7. You have 3 select lines, S2, S1, S0, S0 being MSB, S2 being LSB. One single output line, that is the function f. And here is the truth table where you see that for 3 select lines S2, S1, S0, you have 8 possible combinations that can be applied to the select line. And based on that 8 possible combination, any one of these input data lines gets connected to the output Y or output F here. So now what we have done here, since n equal to 3, a, b, c are the three input variables, here you have named those three variables a, b, c, and they are mapped with S2, S1, S0 respectively. Now we see that the mean terms given are 2, 3, 5, 7. So here in the truth table, this is the mean term 2, where we have marked output to be 1. This is the mean term 3. We marked output to be 1. This is the mean term 5, and this is the mean term 7. You can start from 0 here up to the 7. So accordingly, we have marked the mean terms. Now you want the output to be function of these mean terms. So that what you do here, 2, 3, 5, 7, or according to the truth table 2, 3, 5, and 7, you connect those data lines 2, 3, 5, 7, or in other words, I2, I3, I5, and I7, they have to be connected to the logic 1, here in this case VCC. And rest of the logic input lines I0, I1, I4, and I6, they have to be tied to the logic low, that is ground. Therefore, when you apply a possible combination of A, B, C, or say S2, S1, S0, accordingly, whichever lines are connected to logic high, they will be connected to the output 1, because the output is 1 only for these specific combinations. For other combinations, the output is 0. So this is how you have implemented this Boolean expression using 8 is to 1 multiplexer. Another example here. So here you are given new function, as you can see, which is f in bracket abc, again n equal to 3, that is 3 variables, and it is a sum of the following mean terms. Small m indicates mean terms, that is 1, 2, 4, 7. So for that, we can refer to the truth table first and mark those mean terms accordingly in the truth table. So here is a S2, S1, S0. Obviously, there are 3 select lines and there is a single output. So we are talking about using 8 is to 1 MUX. Why? Because we have n equal to 3. Therefore, according to the previous definition, we are going to use 8 is to 1 multiplexers. So what I have done here, For the mean terms 1, 2, 4, 4 and 7, here the entries or output is 1, 1, 2, 4 and 7. For rest of the input combination of select lines, the output is 0. So what we can do here, as you see, we can use the 8:1 multiplexer again, where the data lines of the inputs are I0 to I7, only mean terms 1, 2, 4, 7, that is I1, I2, I4 and I7 are tied to logic high or logic 1, that is VCC, indicated by this brown color. Other input data lines, that is I0, I3, I5, I6, they have to be tied to ground, that is logic 0 or logic low. Then when you have S1, S2 and S0, which are basically ABC mapped, so you apply the one of the 8 possible combination of these inputs A, B, C, then only when your output has to be 1, these particular data lines, that is I1, I2, I4 and I7 will one by one get connected to the output F only when you have the specific combination of input here. You can see now it is also possible that you are asked to implement a logic function with n input variables, and for that you have to use a multiplexer which is 2 raised to the power n minus 1 to 1 input multiplexer. It means for a logic function with n equal to 1 input variable, according to this equation, you will need 1:1 multiplexer, theoretically. For a logic function with n equal to 2 input variables, according to this equation, you will need 2:1 multiplexer. And for a logic function with 3 input variables, you will need, according to this equation, 4:1 multiplexer. So let us solve this example where you have clearly given 3 input variables A, B, C n equal to 3, and according to this equation or this statement you are asked to use 4:1 MUX. Remember, we can also use straightforwardly 8:1 MUX. However, now the challenge here is to use only 4:1 MUX. So the function is ABC, that is equal to summation of the following mean terms 1, 3, 5, 6. So how do we go about that? For that, what we do is we create a special table called as implementation table. So in this table, first you name the 4 data inputs I0, I1, I2 and I3. We know that these are the data input lines of the 4:1 MUX, and then you have 0, 1, 2, 3, 4, 5, 6, 7, and the first row is labeled as A bar, second row is labeled as A. So once you are done with this implementation table and labeling of the rows and the input data lines from I0 to I3, what you need to do is look at the mean terms given, that is 1, 3, 5, 6. So 1, the mean term, just circle it, 1, 3 and 5 and 6. After finishing this entry and circling the mean terms required, what you observe is for the I0 input data line of 4:1 MUX, there is no mean term to be selected. So you mark it as 0. Therefore, it means I0 input data line of the 4:1 MUX should be connected to logic 0. So before I move further, let us have a schematic of 4:1 MUX where S1 and S0 are the 2 select lines, I0 to I3 are 4 input data lines, enable bar is the chip enable pin of the MUX which is tied to ground, and we see that now B and C are the 2 input variables that are mapped with the select input lines S1, S0 respectively, whereas the third remaining variable A will be used according to these labels that we will explain. So coming back to this implementation table, we say that I naught, no minterm is circled here, therefore I naught should be tied to logic 0. And we see here in the schematic I naught is being supplied with the logic 0. For this I1, both terms, min terms 1 and 5 have been selected. So when in both the rows A bar and A is, though both these min terms are selected, you say that I1 should be tied to logic 1. Therefore, I1 should be supplied with logic 1 here. For I2, we see that minterm 6 is circled because that is what is given in the equation here. If such is the case, we see that minterm 6 is in the row of A. Therefore, I2 should be tied to logic A. Therefore, I2 is tied to logic A. A can be logic 0 or logic 1. Any data can come here. Now for I3, minterm 3 is selected, which is from the row A bar. Therefore, I3 should be tied to A bar. Here we see that A bar is given to I3. So A bar can carry logic 0 or logic 1. Finally, here comes the output of the 4:1 marks. Therefore, for the 4 input possible combination of B and C, you can see that I0 to I3 can be selected one by one. And whatever the logic one of these 4 lines will carry, that gets connected to the output. Here, you are given to implement the following function using 8:1 marks. So clearly there are 4 input variables, that is n equal to 4. So straightforward 2 to the power 4, we need 16:1 multiplexer. However, the challenge here is that we are asked to use only 8:1 marks according to the new definition. So what is this function says? F of A, B, C, D, that is equal to A bar, B, D bar, or A, C, D, or B bar, C, D, or A bar, C bar, D. So here in each of these product terms, we see that one input variable is missing. So here variable C is missing, here variable B is missing, here variable A is missing, and here variable B is missing again. So how to implement this using 8:1 marks? So let us try to solve this. Write F equals to A bar B D bar as given right over here, and in bracket we'll write the missing min term or missing variable. So missing variable is C or C bar. Then for this one, we'll write ACD as it is plus here B or B bar. Then we'll write plus B bar CD. In the parenthesis, we'll write A or A bar. Plus, we'll see then the final min term, the product term here, that is A bar, C bar, D, and then we'll write B or B bar. After we finish this, our job is to expand this. So we'll expand these terms. That goes A bar, B, C, D bar. So that is the first one. Or again A bar, B, C bar, D bar. And then we are finished with this one. Then we'll try to expand again this one now. So it is A, B, C, D, or A, B bar, C, D. Then we come again for this one. So here we'll write A, B bar, C, D, or A bar, B bar, C, D. Finally, we can move to this one and expand this. That is A bar, B, C bar, D, or A bar, B bar, C bar, and D. If you observe that this mean term A B bar C D and here A B bar C D, they are common, so they can be written only once. So we further simplify the logic. We write here A bar B C D bar, or A bar B C bar D bar, or A B C D, or A B bar C D, or A bar B bar C D, or A bar B C bar D, or A bar B bar C bar D. Once we write this, we have got our final mean terms that we can write here in the form of equation. So we can finally write f equal to summation of the mean terms. What are those mean terms that we have to write? So this is the mean term like 0, 1, 1, 0. So that is the mean term 6. So we'll write here 6. Then this is 0, 1, 0, 0. That is mean term 4. So we'll write 4. This is 1, 1, 1, 1. That is mean term 15. This is 1, 0, 1, 1. So that is mean term 11, and this is 0, 0, 1, 1. So that is mean term 3. This is 0, 1, 0, 1. That is mean term 5. And this is 0, 0, 0, 1. That is mean term 1. So finally we'll write function f is summation of the mean terms, write in them order 1, then comes 3, then comes 5, then comes 4 actually. Let me write here. This is 4, then comes 5, then comes 6, then comes 11, and then comes 15. So these are the mean terms you are given. Terms, what is the next task is to create an implementation table. And since we are using 8:1 multiplexer, we see that we have got these 8 input data lines from I0 to I7. Then we have these 16 entries 0, 1, 2, 3, 4, 5, 6, 7, up 8, 9, 10, 11, 11, 12, 13, 14, 15. So, and the two rows are marked as A bar and A. Okay, so what you see here is you got the 8:1 marks where your input data lines from I0 to I7 are there, and we have to decide which line is connected to what. Here are the three select lines, S2, S1, S0, and out of the four input variables, three are mapped with the select lines. Those input variables are B, C, D, and the remaining variable A has to be used in the implementation table. So here now, after we have got these mean terms, that is 1, 3, 4, 5, 6, 11, and 15, we have to circle them in the table. So this is 1, 3, 4, 5, 6, 11, and 15. And then the first row represents A bar, second row represents A, and accordingly we have to see. Since there is no mean term in both the rows here, I naught is tied to logic 0 or ground. So here you see that I naught is actually getting connected to the ground. For I1, the entry is at the top row, which will represent A bar. Therefore, I1 should be tied to A bar. So I1 receives the input A bar through this line after inversion here. So then I2, since there is no circle of the mean terms here, I2 should be tied to logic 0. I2 is tied to logic 0. I3, both rows have the circles of their mean terms. Therefore, the I3 should be tied to logic high or 1. So I3 goes to VCC here. For I4, the entry is the mean term 4. Therefore, that represents A bar. So I4 is tied to A bar. Similarly, I5, A bar, I6, A bar, and I7 is tied to logic A. So this is how we see that. Then after you apply the one of the 8 possible combinations to B, C, D, they are basically selecting the select lines, and accordingly the logic selected will be passed to this function output f. So basically for only these mean terms, the output will be 1. So now you are given this particular equation. Again, there are 4 input variables, which is f of a, b, c, d, that is equal to pi of max terms. So max terms are given, not the mean terms. Max terms are given as in the parentheses. And again, you have to use 8 is to 1 marks. Easily you can use 16 is to 1 marks, but now challenge here is to use 8 is to 1 marks. So what you do again, you go for implementation table where the first row tells you I0 to I7, then the remaining 2 rows represents A bar and A respectively, and then 16 entries from 0 to 15 are there, and what you do here, you are given the max terms, that is 0, 3, 5, 8, 9, 10, 12 and 14. So since they are the max terms, you have to ignore them in the tables. Do not circle them. Instead, the remaining terms will automatically be considered or are the mean terms. So the mean terms in the table are those which are not max terms. And that is how you mark here the mean terms. That is 1, 2, 4, 6, 7, 11, 13, and 15. And then you see that how I naught through I7 should be connected to what logic. So as we've explained, I naught has no circle or mean terms present here. So it should be tied to logic 0. I1 has one circle that is a mean term, and that's in the row A bar. So it should be tied to A bar. I2 has mean term mark 2 represents A bar. So it should be tied to A bar actually, not the 0. I3 should be tied to A because the 11 is the mean term representing row A. I4 has 4, so it should be tied to A bar. I5, it should be tied to A, and so on and so forth. So what you do here, you use the 8 is to 1 marks, your 3 select lines S2, S1, S0, your 3 inputs B, C, D are mapped here, and the remaining input variable, that is A, is used in the implementation table. To utilize this implementation table from I0 to I7, you have to mark and connect those entries. So here I0 is tied to logic 0. So here I0 is tied to logic ground or 0. I1 is going to A bar. So that is why I1 is going to A bar. I2 is going to A bar. So I2 has to be going to be to the A bar. So just have a correction here. I2 should be tied to A bar. I3 goes to A. So I3 is going to A. I4 is going to A bar. This is how we see in the implementation table. I5 goes to A. So I5 goes to A here. I6 goes to A bar. I6 is going to A bar, and I7 is tied to logic 1. So I7 is the only line that is tied to logic 1. Now, another example. What if you are asked to implement this Boolean logic using 8 is to 1 marks? Remember, there are n equal to 4 input variables. The mean terms are sum of these 0, to 13, these numbers are given plus. There are three don't care conditions. D indicates do not care, 3, 8, 14. So how do we go about that? Again, we have a first look at the implementation table. Again, I0 to I7. Then you have the two rows representing A bar to A, and then from 0, 1, 2, 3 up to 7 in the first row, and then from 8, 9 up to 15 in the second row. Once that is done, what is our job is to find out what mean terms have to be selected. So 0 to 6. So here the blue circle 0, 2 and the 6 have been marked or circled. Then comes 10, 11, 12, 13. So here 10, 11, 12 and 13s are marked. The remaining three don't care mean terms or say the terms entries are also selected and they are shown by 3, the red or orange one, 8 and 14. So these don't care conditions are helping us to basically minimize or select the logic functions right over here. So what you do here is you have 8 is to 1 marks, 8 input data lines from I0 to I7, 3 select lines S2, S1, S0. The three inputs B, C, D are mapped, B, C, D are mapped with the select lines, and the remaining input variable A has been used to use and implement this table. So what you see here, I0 has a blue entry of 0, but you with the don't care, this two rows are selected, A bar and A. Therefore, I0 should be tied to 1. Imagine if there is no don't care condition, I0 should have been tied to A bar. So I0 now receives a logic 1. So here goes I0 that is tied to VCC. I1 has no entries marked here. It is tied to ground. So I1 tied to logic 0. Now I2, both entries and both in the row are marked. There should be it goes to logic 1. So I2 receives VCC. I3 also receives VCC. From the table it can be confirmed because 1 is a single mean term in the row A and the don't care also contribute here. For I4, you have number 12, therefore represents A, and I4 is therefore receiving logic A here. Similarly, I5 is receiving logic A here. I6, both rows have the circles marked, therefore I6 has VCC. Finally, I7 has no entries marked in the rows, therefore it should be tied to logic 0. That is how it is done. Then based on these mean terms combinations, these mean terms are selected and available at the output one by one when you apply a specific combination of inputs at the BCD. Okay, so now you are given this another logic where you see that it is said for the given multiplexer circuit, determine the logic function. So what we see here, there's a 4 is to 1 marks. There are four input data lines, I0 to I3, two select lines, S1, S0, S1 being the most significant bit and S0 is the least significant bit. The clearly we see that there are three input variables A, B, and C. The function is of three input variables and B and C are mapped with the select lines of this 4 is to 1 marks and the remaining input variable A has been used as an input to the data lines. So how do we solve this? So what you need to do is we create an implementation table. Here you see that four input data lines of the MUX are I0, I1, I2, I3. There are two rows. First rows represents A bar and the second row represents A. And the eight entries are 0, 1, 2, 3, 4, 5, 6, 7. Once that is done, what you see here, I0 is shown here to be connected or receiving variable A. So we mark here A. Then I1 is also receiving A. So we marked here A. Then I2 is receiving logic 0 here. Therefore, we marked 0. And I3 is receiving A bar. Therefore, we marked A bar. Once that is done, what we can do here, we see that since I naught is tied or I naught is receiving A, the row A represents this mean term, that is 4. Then since I1 is receiving also A, which represents this entry of the row A, therefore we see that the next mean term is 5. Then I2 is receiving logic 0. Therefore, none of these entries in both of the rows should be marked. And finally, I3, since is receiving A bar, the mean terms representing A bar in this row is 3. Therefore, finally, we can see that this multiplexer is implementing the logic of the following mean terms, which is function of ABC, that is equal to sum of mean terms 3, 4, and 5. So hope you found this module useful. If you did so, share it with others for wider reach. Stay tuned for more engaging content like this. Until then, wish you happy learning.